A little theme music to get us started. Here we go with Algebra 1, Section 1-5, the distributive property. Let's talk about the distributive property. So if we have, notice down there under key concepts in numbers, we'll talk about the numbers because sometimes when they don't do the letters that can be a little confusing. We have 3, open paren, 2 plus 5, close paren, and they say that's equal to 3 times 2 plus 3 times 5. So we check it. We go, well, if we added the parens together, like using order of operations, we'd have 3 times 7, okay, and that equals 21, right? And then we go to the other side, and we have 3 times 2 is 6, plus 3 times 5 is 15. We add those two together, and look at, we get 21. So it's proving that that distributive property is working. And then they do another example with 4 open paren 9 minus 7, and they do the same thing. So it's showing you that no matter what you do, whether you add them together or you distribute both sides, you're going to get the same answer. Now this comes in handy. You think, well, why do we do this with the numbers? Why don't we just add them together and multiply? And you're right, use your order of operations. But when we put letters into the mix, that's where it's important. So we're practicing it with numbers so that later when we put variables into the mix, we can use it, all right? Go. So example 1, distributive over addition or subtraction. You want to read that, Cody?
Mm-hmm. Tickets for a play are $8. A group of 10 adults and 4 children are planning to go. Rewrite 8 open parentheses 10 plus 4 close parentheses using the distributive property. Then evaluate to find the total cost for each for the group.
So they want you to distribute that 8 times the 10 and 8 times the 4 and just write it like that. So we would have 8 times 10 plus 8 times 4. We do the math. We got to do our multiplication. We get 8 times 10 is 80.
Yep.
And then what's 8 times 4?
32.
32. We add 80 and 32 and we get 112. All right.
Yep.
So, can you do, okay, now we got check your progress. It says rewrite each expression. So check your progress. Rewrite each expression using the distributive property. So here's your first expression, Drew. You have open paren, 5 plus 1, close paren, 9. And we have to rewrite that. So first Braille, open paren. You remember open paren is an of? Okay, good. This is, yeah, this is a 1A or number 1.
I found it.
Okay. Open paren 5 plus 1, close paren 9, right?
Okay, so
Open paren and of, right?
5.
And then your number sign, 5 plus 1, close paren, which is your width, right? And then a 9, just a 9, and that means times 9. All right?
No, I never thought.
So we're not going to use order of operations now, which might be a little confusing. We're going to practice the distributive property. So we're going to rewrite this. We're going to distribute that 9 times everything on the inside of the parentheses. That's what distributive property means, is that the 9 applies itself to the entire quantity, 5 plus 1. So we're going to rewrite 9, open paren, 5, close paren, plus 9, open paren, 1, close paren. Hi, Kaylee.
So wait.
So we have, if we distribute, we have 9 times 5 plus 9 times 1. So we do 9 times 5 is 45 plus 9 times 1. 9.
Okay.
There you go. And 45 and 9 is 54. Exactly.
Oops, I did that wrong.
I'm not using it.
So let's do the next example. We have 3, open paren.
Where could I get it?
It's example 1B.
Okay.
3, open paren, 11 minus 8, close paren. Okay, so what's that supposed to look like, Kaylee?
Minus 11, which is 3.
Or 11 minus 8 is 3. Now that's if we use order of operations. We're practicing distributive property.
Oh,
So
okay,
then,
so we do 3 times 11.
good.
Which is 33, and then minus 8 times 3, which is 24. So 33 minus 24 is 9.
Awesome. Excellent mental math.
Whoa, okay.
Yeah, I know. Cody's like, wow, that was fast.
8.
Yeah. So distribute the 3 to the 11, so you have 3 times 11.
Well,
And then minus distribute the 3 times 8
Equals 25.
equals 24. 3 times 8 is 24.
Oh, wait, what?
Ah! And then
What?
33 minus 24 is 9.
Uh,
So,
I'm on.
yeah, it said the distributive property can be used to simplify mental calculations involving multiplication. To use this method, rewrite one factor as a sum or difference, then use the distributive property to multiply. Finally, find the sum or difference. So they give the example of 15 times 99, and you'd normally either get your calculator out or you'd set it up 99 times 15 and do the algorithm. But you could also look at it as 99 is the same as 100 minus 1, isn't it?
Mm-hmm.
And if you put a 15 next to that quantity, so 15 open paren 100 minus 1, and then distribute it,
That'd be 1500.
it'd be 1500 exactly minus 15. Well, you can do that usually mentally in your head as
Yeah, that's
1485. Isn't that cool?
Mm-hmm.
Yeah.
You know, that is really cool.
Is that really cool? Let's try another one.
Yeah, it's just easier for me to figure it out that way. That way I don't get lost in all the numbers because,
Exactly.
that's
So
when
we
my
have,
dyslexia comes out and I'm like,
Yep.
and I
Hey,
think,
JJ.
Dyslexia.
I hate dyslexia, man. It's a pain in the
Hey, JJ.
ears.
So under 2A it says 402 times 12, but how could we rewrite that?
400 times 12 plus 2.
400 times 12 plus
No, 12.
12 times 2?
No. 12 open parentheses.
12 open paren,
400 plus 2.
400 plus 2. So you kind of went at it backwards, Kaylee. You did the distribution and then decided to do the quantity, and that's fine. You realized...
I told you, I'm dyslexic.
No, it's not. It's just thinking in a different way.
Okay.
So you did 400 times 12 plus the 12 times 2, and then you realized, hey, I could put that as a 12
Yeah.
open paren 400 plus 2, exactly. And so 12 times 400, that's 4,800, plus 12 times 2 is 24. Then you can mentally add 4,824 and get 4,824. Isn't that cool?
No.
So we practice the distributive property with whole numbers, but really it's not necessary because you could do order of operations and just simplify and do the multiplication, but we practice it that way so you could see how it works. If you have something like an example 3 on page 28 where it says 5 open paren G minus 9. Well, we can't do order of operations on that G minus 9. We can't combine G minus 9, but we can distribute, right? We can distribute that 5 times the G and the 5 times the 9 and rewrite our expression 5G minus 45. See how that works?
Woo.
Woohoo! Let's try another one. They show you another example. It even gets even more, it looks weirder, but all we're doing is just
I
distributing.
don't know.
So letter B states 3 open paren x to the second power plus x minus 1. Now again, all we can do is just distribute that 3 to every term inside our parens because it means
3x squared
good.
plus
3x squared plus
3x
plus 3x minus
minus 3.
Just minus 3 you can write, yeah, or it's the same as negative plus
I know,
negative
but,
3.
You know, I was with Miss Vol
Yeah,
last year.
it's all good, yeah.
Trying
Yeah.
to-
Let's do the example 3A where it says 2 times open paren 8 plus n.
So it'd be 2 times 8
2 times 8,
equals 2 times n.
actually plus 2 times n.
Plus 2 times
There you go. And then we would rewrite that. What's the 2 times 8?
2 times 8 is 4.
16?
Oh, 16.
That's okay.
Ah.
I know it's early. Plus 2n, right?
Mhm.
So 16 plus 2n. All right. Let's do 3b. Now this is where we got to distribute a negative. Notice that?
Yesterday.
Negative 6 r minus s minus t. Now this is going to get a little trickery.
Ooh, yeah, basically.
Right.
Well, negative minus negative.
Negative.
hot.
Good.
Negative
Negative.
on negative is a plus.
So
Right.
it'd be
But
So-
wouldn't it be to be negative 6r
Uh-huh.
plus 5 plus s
Plus 6x.
6x.
Good. Mm-hmm.
minus
minus t.
Oops, but it's
Plus
neg
t.
plus
Right.
t plus 6t. Good. Because
Okay.
we're multiplying. Let's talk about this. If we wrote it out, it'd be 6 times r plus a negative 6. Sorry, that first one should have been negative 6 times r plus a negative 6 times a negative s plus a negative 6 times a negative t. So you correctly identified, hey, if I have two negatives multiplying times each other, I get a positive for negative 6r plus 6s plus 6t. Good job, Miss Lowell. Really pounded those in your head. So Drew, talking about a negative times a negative equals a positive, okay? Okay. Here we go. Read a term is a number.
Okay. A term is a number, a variable, or product, or
Quotient?
quotient of numbers and variables. Example, y,
P to the third?
p to the third, p,
4a.
and
That's a
5g squared
H.
are all
Terms?
terms. P?
Like terms?
Oh, like terms, okay. Like terms contain the same variables with corresponding variables having the same power. I hate these pages.
Yeah.
What the heck?
It's hard. So they give examples, like do you see that they have 2x squared plus
6x minus,
plus 5. All of those are terms, the 2x squared, the 6x, and the 5. None of them are like terms. 2x squared is all by itself, 6x is all by itself, 5 is all by. We can't combine any of those. I try to remind students, look to see if they look for the same company. And 2x squared works for the, yeah, x squared works for company x squared. The 6x works for the company x, and the 5 works for the constants. Now the next one over, they do 3a squared plus 5a squared plus 2a. Now you have three terms, 3a squared plus 5a squared plus 2a. You can combine the 3a squareds and the 5a squareds. It's like having 3a squareds, it's 8a squared plus 2a, right? This combines with the distributive property. For example, we go backwards. We could say we have 5n plus 7n. That's the same as 5 plus 7 in parentheses times n. You see that? So that just says that these are equivalent expressions. 5n plus 7n, we factor out an n, and we could write open paren 5 plus 7 close paren n, and it's the exact same. It's the equivalent expressions. And it's an expression in its simplest form, okay? So let's practice combining like terms on example 4. So we have 15x plus 18x. Do they both work for the same company? So we can,
15
yep, 15 plus 18,
plus x.
which is 33x. Excellent. All right, let's do another one. We have 10n, this is letter B, plus 3n squared plus 9n squared. What can we combine there? What terms can we combine?
The 3n squared and the 9n squared.
Right. So we would end up with 10n plus what, Kaylee? 12n squared. Excellent. See that, Drew? Yes. So on the check your progress, it says 6t minus 4t. What would we end up with equivalently? 2t. 2t. All right. And then we have b squared on letter or 4b plus 13b plus 13. What, can we combine anything there? B squared plus 13b plus 13?
No.
Nope. So it's already simplified. So if you get that in your classwork and you can't combine anything, you just say simplified. All right? Okay. There's one last item that we need to read about. You want to read that, Cody? That says the coefficient.
The coefficient is 15, and in 3y squared over 4, the coefficient is 3/4. In the term m, the coefficient is 1, since 1 times m equals m by the multiplicative identity.
Multiplicative identity property. Remember we learned it?
What are you?
Wow.
Yeah, let's go over that again. So Cody was reading the coefficient of a term is the numerical factor. For example, 17x. The coefficient is 17.
Oh, okay. I was reading the right thing.
Yeah.
I didn't hear him. I just heard the coefficient.
Yeah, me too.
Yeah,
Yeah.
I did
So
too.
I'm going back over.
Like,
That's
what?
okay. That's all right.
So I was reading the same
Yep.
thing.
So
Okay.
3y squared over 4. Notice that you take that 3/4. That's the coefficient. 3/4. And then when a letter is just a variable is just by itself, it always has a 1 sitting next to it. That's its coefficient. And the coefficient just means how many of those do you have. In the 17xy, we have 17 of them. In the 3/4 y squared, we just have 3/4 of a y squared. In the m, we just have 1 m. Okay? All right.
Oh, we do.
So to recap, we did the distributive property, which means that you have a number on the outside of a parentheses, like 2, open paren, 8 plus n. That means 2 times the quantity of 8 plus n. So you distribute the 2 times the 8 and the 2 times the n. You can rewrite it if you want. 2 times 8 plus 2n. And then simplify that 2 times 8 to be 16 plus 2n. And then there was a discussion on terms, and more specifically like terms and unlike terms.
That right, did
And remember that you can combine like terms.
6.
So 2x squared plus 6x plus 5 are terms. These are all terms, the 2x squared, the 6x, and the 5. None of them are like. They're all unlike terms. We can't combine any of them. X squared is different than x, and which is different than 5. But if you had 3a to the second power plus 5a squared plus 2a, you could combine your a squareds, because they both work for the company a squared, so we'd have 3 of them and 5 of them for an 8a squared plus 2. And then finally there was a reminder of what coefficients are. This is telling you how many of something you have, how many of a term you have. So for example, 17xy means there's 17 xy's. So for example, if you have 17xy plus 3xy, you could combine those, and you'd have 20 xy's.
Hey, JJ.
And for a letter all by itself, like m, the coefficient is just 1, because that's all you have is 1m.